Hello, everybody. Welcome. My name is Santiago Zarate, and today I will be talking about shortening the feedback loops between R&D and the real world with SUSE and openQA. The agenda for today is short, so I'm going to go a little bit about who I am and my experience. I want to talk a little bit about openQA and how can it help. Then I want to introduce you to three different stories and then go into the final words. Originally, I'm from Caracas, Venezuela. I have lived in a couple of different countries, and I used to be a developer. But on my previous job, I was working in a company that was doing electronic voting systems. Uh, so I have been around for a little bit. So since 2012, I was working for this company, and I really want to focus on what we were doing during the following year. So back when I was QA lead in 2013, for Project A, we, for instance, started to set up the initial automated test, the initial test plans, and the base operating system. So, and then a couple of other things. By 2004, I was a generalist, so I was doing a lot of things. And one of my main tasks was customizing the OS. Eventually, I got to the QA lead, functional QA lead for the 2016 general elections. And for those into quality assurance, I was basically doing the plan, do, study, act plans checklist from Demings. Now, why does it matter? Why is it really relevant? Why I'm talking about it? Well, in reality, this is a quote from Edward Demings. He's the father of quality, and it says, "Without data, you're just another person with an opinion." And this is super important because this is what I want to bring to the table. So I want to show you what an election looks like for Venezuela. So they are big. So this was for 2015 parliamentary elections, where we are having uh, 40,000 machines being deployed, where half of the country, or a little bit more than half of the country, is an eligible voter. So you can imagine that there is a lot of testing because there are multiple devices being connected, because you never know where the devices are going to end up. And all of this all together, you need to make sure that it's working. So what we are seeing here is a ballot, so two electronic ballots being connected in a series, connected to the machine and connected to the voter authentication device on the left. And all of those work together. And there is a lot of testing that needs to happen so that that thing that only needs to work well on one day behaves the way it should be expected. And if it fails, we know why and how to fix it or how to replace the machine and still keep the votes. Now, the elections in the Philippines are much bigger. To give you a figure of a speech, in 2010, it was 250 million euro being being put into all the election. For the 2016 elections, the number was different, was much different, but still, it was 92,000 machines that were being deployed. And this is where mostly my focus was, just making sure that that thing was working well. And we are having uh, close to 45,000 candidates, and all of that is being they are being chosen by almost 60 million eligible voters. And this machine had a couple of things. So you have headphones, so you need to take care of the accessibility part. You have also security keys, paper, and a couple of other things. You have buttons, you have USB ports, you have SD cards. So there are a lot of things that you need to make sure that they are working. And if you think about it, uh, so an election is expensive. And what you're seeing right now is for the 2020 Philippines elections that just happened. And just the part for the automation, the part for the voting machines and the election software is just 56 million euro. And that is 67% of the total budget that Comelec had assigned. So there is a lot. There is a lot. Now, there are a lot of parts in the election that most people don't see. So you have to develop the hardware, you have to develop the software, you have to get servers, get transmission services, you have to prepare the software that is going to do the election reporting. You have to do and deploy the software that is going to do the election management, election configuration, and all of that needs to go through the certification and audit, only so that you get to the election day. Because for elections, so unlike normal projects, you have a day that is kind of flexible, but when it comes to elections, you just can't. You have a date, you stick to the date. Now, I will be back to that slide in a minute, but right now I want to talk about openQA. Where does it fit in all of this? Well, I like to talk about openQA as a puppet and also kind of the puppet master. So you basically write the test and you explain openQA how do you have to interact with a particular device. So if you want to disconnect a network cable, you tell openQA, yeah, disconnect the network cable from that machine. And it has multiple ways to interact with the machine. It can be plugged into multiple continuous integration tools. So you can go with Jenkins, you can go with GitLab, and you can go with Open Build Service, for instance. So, and I like to say that it's a continuous testing tool. And this is the heart of how at SUSE we are able to make sure that almost everything is being tested. So from the submit request to having that put into the ISO that is going to be delivered to the partners or to the partners, clients, and even all the images that we are building for OpenSUSE, they all go through OpenQA. Now, uh, the connection. Let's see. Let's really talk about what we are here for. And this is why I brought you three stories today. And I want to focus on the whole parts that almost nobody sees. And I said that I will be back to that slide. So let's talk about a personal story. This is me. About how during the testing phase, uh, we were running a trusted build, and we had tests that were failing in one out of three locations in different time zones, and these tests were needed for certification. So an election is kind of, so basically elections are regulated one way or the other. And for the Philippines general elections, we had to go through the what we call the VVSG, so voluntary voting system guidelines. There are multiple levels, so there is federal, there is state level, there is district level. But then on top of that, we had to fulfill some requirements about MISRA. So if you work with C++, you kind of know what this is about. And then on top of that, we had to go with security certifications, so FIPS 142. So there is a lot that needs to happen. And a trusted build is kind of an all or nothing process that is happening a couple of days before, well, weeks or months before the election day, where it's an all or nothing process. So everything has to be built from the sources, and everybody has to see that that is happening. The hashes of that build are being distributed to the public. And in our case, it was taking up to 7 hours because it's downloading the software, building the software, creating the images that are going to do the build for the other machines. So it's kind of a very long process. And our problem was that at some point, because we're humans, we got used to everything working. So there was one moment close to the moment when we had to do the certification, that somebody was reporting that the trusted build was failing. And then we have 3 locations, and we were wondering, why is it failing? And part of the problem is that there was a change in the script that was doing that was preparing the trusted build. So we didn't realize, because we got so used to it working, that the very crucial step of just disconnecting a USB drive was really not happening, because we needed to reconnect it again. And we at times we had 20 USB drives over our desks or over the lab, and they were always getting mixed up, because one had one type of certificate and the other had another type of certificate, and it didn't matter that we were marking them. It was always happening. So we kind of got used to never disconnecting it until and it was a lot of testing. So the tests, not all of the tests were being peer reviewed, the execution of them. And what happened was that we got one new person, and we start to check the documentation. So we were testing the documentation, and she's reporting that the trusted build is not happening. And the first thing that we think is, because she's new, something is going wrong, but it's because of her. And in reality, it wasn't because of her. It was because we got so used to everything working that we weren't really going into the detail, and we didn't notice when this script changed. So we got close to a deadline, or to missing a deadline, just because we are humans. We want to save time. We are tired. We are basically overworked. And this is the part where openQA can help, because it can help to automate those builds, generate the ISOs and the OS images that go into the voting machines, to generate data, multiple types of data, including emojis. And then you just set up an automated testing environment that is preparing your laptop, that is running the trusted build. And when it's finished, it installs it on the servers. It deploys it prepares the data, deploys that data into the transmission server, into the election management server, and you can also deploy that into voting machines. Uh, so it depends on where you want to stop, and you can use it to validate user interfaces, hardware, data, machine integration. So the thing is, it could have helped us to achieve so much, because we didn't have we weren't doing peer review everywhere. We had a lot of the teams on the verge of burnout. Running end-to-end tests could take days, because there was a lot of manual setup. We had some automated tests, but they were not all integrated. And the data integrity checks were painful, because just imagine filling a ballot and filling each thing, putting that on a spreadsheet, and then manually doing all the calculations. So it's a lot. And here's where openqa could have helped. We could be, if I knew that it was there, uh, everybody could be home for dinner. We could have peer-reviewed tests, so nothing is being committed if it's not being if it's not being reviewed. We will have less stress doing milestones, and we will need way less manual testing. And just to give you an idea, so we were working around 16 hours a day, depending on the time, and it was 16 hours a day per engineer across seven multiple teams, because we have multiple levels of testing, and there was one team in particular that was in charge of testing everything all together. So just imagine how expensive that is in terms of people and in terms of money. Now, I will finish here and I will bring you to the second story. So a Heisenbug is a bug that is happening only when you're not looking at it. And in the case of Donna Bay, she was trying to hunt for one of these bugs. So she was in this stage. It was very early stage of development, and there is software being developed across along the hardware, but they not necessarily have the same revisions for everything. So nobody's testing exactly the same thing at the same time, because we have a lead time of about 6 weeks for a new hardware revision. 6 weeks is a matter of speech here. And the problem is how, when you have so many things all together, when you have so many small things that you need to verify, something can fail and something will fail, and something actually failed. So, you know, but in reality, everything is testable if you try hard enough. And of course, there are small parts. So testing the printing of paper is kind of something that you can achieve, but it's a bit difficult. But the problem is that with Donna, we were trying to. So there was one bug in the optical recognition, and it was basically hanging the machine from time to time. And catching that bug took so much time, because there was a team in the Taipei office, there was a team in the Panama office, and working, trying to make sure that all the teams were in sync was just painful. So the firmware was being developed in UTC +8, and the software was being developed in UTC -5. So there is a lot of time in between, and the operating system is also changing, because I am there by this point, and the requirements could change, because by then it was still not Philippines 2016 election. It was just a project. So and the consequences is that basically Donna could not stay late, so because she had to pick up her kid. And then other software developers could also not stay late, because they also have a family that they need to take care of. And the setup was kind of tedious, so we needed to put the software into an SD card, load it into the machine, and usually QA was piece of um, the last piece of the Lego to come together. So we were usually notified super late that there is a new version. So at times I was at 3 a.m. in the morning just waiting for a build, and you know, overworked. And then the thing is, how how do you automate tests for this with something that looks like this? Um, Now, in reality, you just fake it until you make it. So I just want to focus on two parts of openQA. So this is the web UI. So it looks, it's the part that interacts with the user and so on and so forth, and the scheduling part. But I want to focus on the backends. We have multiple backends. We have we support multiple type of machines, so real hardware, IPMA. But right now, I want to just focus on backends and talk specifically about real hardware. Now, if you have your phones out again, you will see that there is a QR code, And right now, this is an overview of the backend or how the testing for Raspberry Pi is working right now. We are using a small gadget that is called SD Wire, and we basically connected all that into one switch, and we put a keyboard on it, and it's working. You can see the real thing. So, and this is what we are using at SUSE and at openSUSE to do testing on real hardware, and and so on. OpenQA also supports IPMA, but let's not get there. I want to tell you that our friends from Cubase, QB, QBOS, they are doing that with a laptop as well. So they put a servo motor in a Raspberry Pi, and they are controlling it. So there is a power switch being activated, and this is all being controlled via OpenQA. They are using the Intel AMT extension, and this allows to take full control um, of a laptop. So, and then there is the QR code as well. You can scan it and you can look at it. There is a very nice write up by one of our friends there. So, how could have OpenQA help Donna on moving on being able to hunt for a bug? Well, uh, if you think about it, let's say that you are able to boot the machine automatically. You can connect a CI from the moment that you have a new firmware release to put the machine in bootloader mode, load the firmware, then pull the operating system, and then on top of that, install the new version of the software. And if you have automated tests that were catching that specific bug, we will be already on the other side of the road. It will help us to scale and grow organically, because the less humans will be needed for the whole process. So there are a lot of things that we can do if we start automating even more and more. Now, Hellberry is the third story, and we know that Murphy's Law can happen. Murphy's Law is there, it lives with us. And in her particular case, even after 10 elections, it was still there. So things could go wrong because this is her field of operation. So she has to work on all of this. And things that can go wrong. Well, the end-to-end testing has to happen at the end of the project. You risk the project going over budget. We're just going through a pandemic where we are having a global supply chain crisis. So you need to make sure that all of the pieces are there to be able to build 95,000 machines average. And well, war can happen. And OpenQA can help with the auditing because you can, let's say that you have to go through common criteria, that you have to go through HAIIPA, this one that is for healthcare. OpenQA can help you to achieve a lot of things to ensure that everything is being put in the right place and that it won't fail. Because in reality, if it's a puppet, if you think about it as a puppet, as long as the tests are being peer reviewed when you are creating them, you will not have the risk of having OpenQA making a mistake, forgetting to disconnect a USB drive, forgetting to disconnect the network cable after the transmission has finished. So if you are developing systems, embedded system for railway, for healthcare, If you are working in the aerospace industry, OpenQA can help because if you remember, or if you didn't know, now you will know that the SpaceX, the panels that they were using in SpaceX, they are using Chromium or Chrome. I don't remember which one, but it's just a browser, and it's a browser that is embedded in a full in a rocket. It's being sent to space, and you need to make sure that it's working well because astronauts' lives depend on that. And what can you do? Well, you take OpenQA, you put it, you set it up very nice and tidy, and then you put Selenium on top, inside of it. So you start testing the web interface with OpenQA. Or if you need to test a touchscreen for because you are building a ticketing system that is going to be, pressed all the time by the users, you can take the part that is translating the signals from analog to digital. You can also connect that to an Arduino, connect that to a Raspberry Pi or another device, or if you have debug parts on it, you can also fake and simulate the data so that you have everything connected from the moment you are just developing the hardware to the moment you are getting to audits and certification. So there is you can go the whole chain and the software development life cycle, and you can use it for the hardware development life cycle. So it can help also manufacturing. Now, I want to leave you with a quote from myself. And that is that I believe in the philosophy that we are humans, not robots. And when it comes down to testing, my money is going to be on the robots because a robot will not get tired, it will not rest. The only thing that it needs is to be connected somewhere to electricity so that it can be powered. And the important take here is that automation on multiple levels can happen. And one thing that you can do is always think of automating first, or rather, ask yourself the question, how testable is the thing that I'm building? And you can test documentation, you can test software, you can test hardware, you can test a solution. What you need to do is sit down and look at it from a little bit outside of the box. Now, uh, thank you for attending my presentation. If you want to know more, you can find the code in open.qa, and it will take you through the different places that you need to check. The GitHub organization is os-autoinst, and our Twitter is openqahq. You can follow us there, and you can also find me on Twitter as 469, and I'm available via email santiago.zarate@suse.com. Thank you and happy testing.